Hi, it's Naomi here, and I would like to talk to you about how we use methods of association when reviewing the literature. So the paper that I'm going to use is one that looks at the success of rehoming dogs in the UK, published in 2008 in Preventive Veterinary Medicine. Just to give you a little bit of context, they took various dog shelters in the UK and they conducted a study to determine which factors affect the success of rehoming. So this is an analytical study, and it was actually a cohort study in which they followed dogs for 6 months post adoption to see what factors influenced whether or not they stayed with the family or had to be returned to the shelter. So when you look at this paper, or any paper in fact, you're going to come across a statistics section which is going to look really like it was written in hieroglyphics. Now, we're not expecting that you, as a result of this course, are going to be able to decipher this section and really understand everything that's there, but you can approach with a little bit of understanding, which is that the first sentence there, describe and descriptive and univariable analysis were conducted using cross tabulations and so on, and they calculated an odds ratio. Now they've given you some details about how they did that, which is more or less irrelevant to you at this point. Just know that you're going to see some odds ratios somewhere in this paper, and they've done those using a logistic regression model. Now they're going to be interpreted exactly the same as you would interpret them, and they are going to mean exactly the same thing. Okay, some highlighted sections that may mean something to you as you skim a statistics section is that there is reference to a multivariable model and also a Cox regression model, which is another form of multivariable models. Now, the reason multivariable models are important is that they tell you that there has been an adjustment. Okay, and I'm going to take you through what that means. Alright, so if we go to the results, you see a section here which talks about univariable analysis, and the authors looked to see if 93 variables were associated with the outcome, and I've taken that from somewhere else in the paper. They haven't actually shown us the specific results because there was way too many there, and for them to do that. Other papers will show you those results, and they will use tables normally, and the tables might have things such as univariable analysis or unadjusted odds ratios. They then took a subset of those that they deemed to have some relationship with the outcome, and they decided a final model through an elaborate process of model building. Okay, that detail you don't necessarily need, but the fact that you saw multivariable in the methods section suggests to you that somewhere you're going to see a table like the one that I've got here with the word multivariable, and it might be conditional, might be used instead, but you'll see something to that effect which has odds ratios and 95% confidence intervals in it. There may be other things in the table as well. This is a fairly clean table, but you can ignore those and just focus on the odds ratio part of it. Now this table actually goes on for quite some distance, and you can see that there were a lot of different variables in that final model. So I'm going to just step you through how we interpret them, and the truth is we interpret the odds ratios with very little difference. So let's narrow in on the dog was sick soon after adoption. What you see here is a 1. Sometimes you will see the word ref, which means it's the category that's been compared to. And so it's saying if the dog was sick soon after adoption, it was 3.2 times more likely to have an unsuccessful adoption. That value, though, could have ranged to 0.9 to 11.7. Now you'll see that that actually is labelled as highly significant, even though that ratio crosses 1. That's to do with the different ways in which we can determine statistical significance. And the way I would interpret it in those cases where you might see a statistically significant value out here but a value crossing 1 is simply to say that, you know, there is a lot of range in the plausible values. But the other key point in this is that we have an odds ratio of 3.2, and this is after adjusting for everything else in the model. So that means that we've considered owner's age, whether there was children, behavioral problems, everything that you see in the table, and they'll normally show the whole model, has been adjusted for or controlled for, might be another word that you'll see. Now, the other sort of things that will crop up when you start to look at these tables is, and I'm going to narrow in here on the size, is that you'll notice that there is 3 levels here. We have an odds ratio of 1, which again is our reference category. We have a 1.8 and a 2.1. So the question is, how do you interpret that? Okay, and so what it's telling us is that the 1.8 is compared, so the medium dogs are compared to the small dogs. The large dogs are also compared to the small dogs. And so we say when compared to small dogs, medium sized dogs are 1.8 times and large dogs are 2.1 times more likely to have an unsuccessful adoption after adjusting for the other variables in the model. So again, because this is a multivariable model, another way it may have been written was adjusted. So if you get told something is adjusted, or it's from a multivariable model, or it's conditional, what it's telling you is that it has controlled for other factors. And those other factors will be the other variables that appear in the table with it. Key takeaways. If the interval crosses 1 for the 95% confidence interval, we would generally say there's no significant difference. That can get a little bit tricky when we start to unpack multivariable models where we have 2 different ways of assessing significance. Univariate or unadjusted means that the ratio does not account for any other factors. If you see the words multivariable or adjusted or conditional, it means that each ratio has been adjusted for all the other variables in the model, and those variables are normally shown in the table. So at this stage, this is something you learn through practice, so you're going to have an opportunity to start looking at some papers, and I would encourage you to perhaps go back and look at some of the analytical papers that people submitted on the forum around objectives in epidemiological studies, and just have a look at reading the tables. As always, any questions, comments, put them in the forum. We'd love to hear.